Hello, welcome to tutorial number 12 for COMP335. In this tutorial, we'll be looking at designing Turing machines. Let's solve question number 1, which is to recognize this language L equals 0, 1 star 1, sorry, 0. So here the accepted strings would be 0, 1, 1. You can have however many ones you want here, and then it'll always end with a 0. So let's see how the tape would look like for an example string. So let's take the example here. So this will be our tape, and we have a 0 because all strings that accept in this scenario are beginning with a 0. And then you have ones. There could be 0, 0 or more ones. So here let's say there are 3 ones. So let's put 1 here, and then it'll end with 0. And here we have the blank symbols. So this is our tape. All right, so let's look at the string. So your read head, write head would be here, and for us to begin with, let's see how we can consume this language. So first we can see that it should always begin with a 0. So let's start with the automaton here, which is, say, Q0. So, and we have our read write head at the first one. So we would only accept the string if it starts with a 0. So the first one would be, the first transition here would be always consume a 0 and then replace it with 0 and then move to the right. So after the first transition, it would look like this. So this is my read-write head. So this would be here. So now at Q1, we want it to consume 0 or many ones. So we can do that by introducing a loop here. So the loop would be something like this, where if we see a 1, then we write 1 there, but then we move to the right, and then we keep on doing this until we run out of ones. And then at the end, when we run out of ones, then we expect a 0 to be always there because it has to end with a 0. So then we can have our third state, Q2, and the transition would be 0 to 0, and then we move to the right. And now the read write head is the read-write head is over here, and then we consume that 0, and the read-write head would move to the last symbol, which will be a blank symbol. So in that case, we would have our final state, which is Q3, and we can accept the blank space, and then we don't do anything here, and then we just move to the right. So this would leave us in an accepted state. And for any other transition that are not drawn, they'll always result in a rejection state. And one more thing we usually need to check is if the string can be empty, but then in this case it cannot be. It has to have at least 2s. So in that case, we don't have to deal with the empty string case. So this Turing machine would accept any strings of this particular format. Okay, so let's move on to the second question. So the second question is this language where you have n zeros followed by n ones, and here n is greater than or equal to 0, which means it can be an empty string. So let's see how we can design a Turing machine for this one. So let's take an example string like before, and then let's put that on the tape here. So assuming we have an infinite tape, we have an infinite tape, and we have, let's say, 0, 0, 0, and 1, 1, and 1 here, and then we have blank symbols elsewhere. So here n is equal to 3. So this is an example we can look at. So for us to solve this, the rough algorithm that we could follow is to basically consume a 0. So let's say our read write head is here. So read write head is here, and then we consume this 0. So let's say we consume that 0, and then we will be, let's say, let's replace that with an x. So now that we consumed it, then we can just move to the right until we find a 1. So then your read write head would move all the way over here until it finds another 1, and then if it finds another 1, then it would replace that with a y. So let's and then once it finds a y, then it can move back to the next leftmost 0. So that would be this one, and then it replaces that with an x, and then it moves on to the next closest one, and then it keeps on doing until we run out of zeros. So once we run out of zeros, then we just move to the right, and until we find the blank space, and until we find no more ones or zeros. So let me just show that. So here once we're done with all the zeros using that algorithm, we will be left with this string on the tape. And then we would our read write head would be here. So once it writes all the it would come and stop here, and then we can basically move to the end of the string, so that we can confirm that all the strings are all the characters are consumed. So once we have this, then we can just move from here to all the way till the end until we get a blank space, and then at that point we are done, because all the strings are marked as either all the ones and zeros are marked as either x or y, and if you don't find anything else, then the string is accepted. So let's see how we can implement this using the how we can add the control part for this. So let me just replace it with all the zeros and ones. Okay, so this is how we would begin, and For the start state, let's throw Q0 here. And as we discussed earlier, this one can go to 0, so there is a possibility of an empty string. So if it is empty, then the first thing we read will be a blank symbol. And in that case, we just accept it right away. So let's keep Q1 as a final state, and if we find a blank state, then we just write the blank state, and then yeah, we can move either left or right, doesn't really matter, and we just end we just accept it, and then that'll be the last state. So that takes care of the empty string part. So the next one will be the algorithm that we discussed. So for that, we know that the string always starts with a 0. So let's do that. As the first transition, for any non-empty string, there should be a 0 in the beginning. So which means our third state Q2. So this will be consuming a 0, and then let's replace that with an X, and then let's move to the right. So now our head will be here, and this will be an X. So now we need to find the next one. So for that, we can just loop around until we hit that 1. So for that, we can basically do a loop here, and if we see a 0, then we would write the 0 back and then move to the right. And then we plan to use Y as a marker for ones. So for that, if we see a Y, then we would like to keep that Y on the tape and then move to the right again, so that we would find the next one. So this would move our head from here all the way till here. So now we have a 1. So now let's add another transition for that to consume that 1. So if we find a 1, then we'll move to the fourth state, which is Q3 here. And here the transition would be consumes 1 and then replaces it with the Y, and then we move to the left. So now what would happen is that we take the 1 from here, and then we would replace it with the Y, and we will move the head one step to the left. So now we're back at that 0. So now we want to go back to the leftmost 0. So for that, we can just loop here again. So for this one, we would see if we see a 0, then we replace that with a 0 and then move to the left. And if we see a Y, just in case, we would again write that Y back and then move to the left. So this would bring us all the way back to till here. So then since we always expect a 0 at the beginning here, and then consume that 0 and replace it with an X, then it is guaranteed that there will be an X at the beginning. So we will reach that X after this loop. So once we get there, then we can just start over with this algorithm. So then we can just move to Q0 like this, and when we're going to Q0, we consume that X and then we replace that X, and then here we move to the right. So when it reaches Q0, we will be set like this. So then we just start from the 0 again and then do this whole procedure all over. So let's do the second one. So here the 0 will be replaced with the X, and then it will it will loop over any zeros or y's, and then it'll reach a 1, and then this 1 will be replaced by a y, and it will move to the left, so we'll land here, and this one will be a y, and then the head will move back to left every for every 0 or y it encounters. So it'll go all the way till the x, and then when it sees an x, it'll just replace the x with the x and then move to the right. So it will land on the 0, and then from here again we replace that with an x. So let's just replace this with an x. So there's an x here, and then we repeat. So we will keep moving to the right until we find a 1. So that'll be this one, and then if you find a 1, then we would replace that with the y and then move to the left. So here this will become a y, and then we would keep on moving to the right till we find an x, and once we find an x, then we would move to the right from there. So we'll land here. So now this is where the algorithm would lead us. So now before we accept it, we need to ensure that there are no remaining ones or anything on the tape. So for that, we can just move to the right until we hit the blank space. So for that, we can have another transition here. So if we find a y from this point, so let's have this transition Q4. So if we have a y, then we replace that with a y and then move to the right. So that means if we find a y after we reach Q0, which will only happen when we have consumed all the zeros, then we would just move to the right, and then we can just keep on doing this until all the y's are consumed. So that would be here. So let's add a loop to do that. So that means we'll have a loop here, and then y, and then we move to the right. So at the end, if we reach a blank space, then that means that there are only y's on the tape, and we would only replace a y after we find a 0. So there will be one y corresponding to one x, and then if there are only y's left on the tape, that means that we have consumed all the simples. So in this case, if we reach this point and find a blank space, then we are done. So for that, let's add the transition. So if we find a blank space, then we just replace that with the blank space and move to the right. Again, this doesn't really matter because that's the end of the transitions. So this alternator should, this Turing machine should accept the string 0 to the power n and 1 to the power n for n greater than or equal to 0. All right, so that's question number 2. And for question 3, so it's sort of an extension of the previous question. So earlier we just had 0 and 1. So now we have A, B, and C. So we have 3 different characters. So for this, you can use the same algorithm, but then you would need one more marker. So we'll use X, Y, and Z to mark those three different characters, and then we can just use the same algorithm here. So instead of doing instead of marking it twice, we have to do the marking thrice here. So let's start with an example as usual. So an example string would be something like this. So we have A, and B, and C, and we have blank space over here, blank space over here. So this is how our tape looks like. So from here, let's see how we can construct the Turing machine. So As usual, we need to check the empty string case. So this can be empty because the n is greater than or equal to 0. So in the empty case, we should, the tape will be empty. It's full of blank symbols. So let's handle that first. So for that, we will start with our initial state, which is q0, and then if it is empty, then we would finish it off at q1, which is the final state for that. And for that, if you see a blank space immediately, just do a blank space and then move to the right. It doesn't really matter where we move. So this would accept the empty case, and after that, it's very similar to the previous algorithm. So we will have a head here. So this head would start here. So we would mark A as X, and then once we find this N, then we will keep on going towards the right until we find the first B, and then we'll mark this as Y. And then instead of coming back to the leftmost A, we would just keep on going until we find the next C, and then mark it as Z. And only after that we would come back to the leftmost A. It's very similar to the previous one, but then here we have to do both A and B, and then come back to A. And then we repeat until all of them are covered, and then we just verify that the tape contains nothing but the markers. So let's see how that's done. So for that, so we know that for all non-empty strings, the string always starts with an A. So let's use the same technique as earlier. So for the first transition, say we are moving to Q2, then we take the A and then replace it an X and then move to the right. So this would, as usual, this would move this over here, and this would become an X. So now we want to find the next B. So for that, we can use a similar loop as earlier. So here the transitions would be that if we find an A, then just keep that A and move to the right. And then there could be Y, which is the marker that we're going to use for B. So if we find the Y, then replace the Y and then move to the right, and then keep on going until we find a B. So once we find a B, so this would land us over here, because it will skip over this A and then it will land on this B. So now once we are at a B character, then we can just replace the B character with a Y. So here if we find a B, then replace the Y and then move to the right. So earlier we would move to the left, but then here we're not done. So we still have to look for the C character. So that's why it is different. So we have this one over here. So now what just happened is that this became a Y, and the head just moved over here. So now we want to do a similar loop here, but then for the C character and this marker for that. Sorry, for the B character and the marker for C character. So after we replace the first B, then regardless of which B we find, we just keep on moving similar to the previous one. So here we keep on moving till the end. So we would move from here. So for each B, it will just keep the B and keep on moving. And if we find any Z, we would keep the Z and then keep on moving. And this will take the head from, sorry, the head just changed color. Okay, so this will move the head from here till here, so until it hits the first C. So once it hits the first C, then we can just replace that with our no, we can just replace it with our marker character. So here, let's say we have Q4, so we would have a transition here, and then whenever we find C, then just replace it with the Z and then move to the left. So what just happened here is that we just replace this C with the Z character or Z character, and then we just move to the left. So now we want to go back all the way till the first A character. So for that we want to do another loop. So let's do that. So let's do a loop here, and the transitions would be that any Z that's already there, if we find a Z, then put the Z back in and then move to the left, and any B's that we find, put the B back there and move to the left, and for any A's that we find, we would want to put the A back on the tape and then move to the left. So yeah, we will also want to do the Y as well. If you find any Y's, then we want to put the Y back on the tape and move to the left. So this will cause it to move all the way back to the first or the rightmost X, and that is it, right next to the leftmost A. So it will cause it to land here, and then from here we just like the previous one, we can just go back to the beginning. So from here we consume that X and then leave it as is, but then we would move to the right. So this would take the head from here to here. So then we can just repeat the whole process until we consume all the A's. And since we have all the number of A's, B's, and C's are the same, then after we're done with all the A's, this should cover all the B's and C's as well. So now after all the symbols are done, similar to the previous one, let's see. Let's just mark these as. Here we'll have an X, and then here we have a Y, and then here we have a Z, and it will land on this. The head, after consuming all of that, will land on this Y. So after this, we would like to ensure that there are only Y's and Z's after that. So what you can do is you can basically have two more states. So first one would be Q5, and here the transition would be Y, and then we put the Y back in there, and then we move to the right, and then loop over any remaining Y's. So here Y and R, and then once we are done with all the Y's, then we can do the Z's. So for that we have Q6, and we have this transition over here, and then for Z we put back the Z, and then we move to the right, and then for all the remaining Z we will do the same thing, Z and R. And once we are done, and then if the next one is a blank space, then we can accept this string. So we have this transition over here, which is blank space and blank space, and it doesn't really matter where we move the head afterwards. So once the head is over here, so once it goes over all the Y's and Z's, it'll land here, and then if it is a blank symbol, then we can just accept the string. So so this machine should accept all the strings of this form in B and Cn, and yeah, that's the end of the tutorial. Thank you.